Okay, this is going to be mixed exercise 5 from year 2 mechanics. And we're going to do questions 2, 7 and 8. So this question 2 is really annoying because the only thing that's difficult about it really is just the rearrangement. The actual skills involved are no more difficult than a lot of questions, so it's just kind of hard for all the wrong reasons. But we do need to know how to do all these algebraic manipulations. So let's start off with this. We need to resolve all our forces. This 90-degree here at the moment isn't helpful because we always want to know what the angle is between the axes, either the x or the y axes. So we need to fill that in as 70 degrees there, because 90 take away 20 is 70. So that 70 is going to be useful. The 90, we don't want to be using that in our calculations. And then I'm also going to change that to be a 30-degree angle and ignore this 60 here. The reason why I'm doing it is because I want to have all the angles between the x-axis, because the other two have got it between the x-axis. So I just feel like for uniformness, we'll take that one between the x-axis as well. You'll see in a second how it just gets our causes and sines to be lined up. Whether it makes it any easier, I'm not sure. I just prefer it like that. So let's do all our vertical forces first. So this is going to be F1 sine 30. This is going to be F2 sine 70. This is going to be 20 sine 20. And then our horizontal forces, we will have here F1 cos 30, F2 cos 70, then I'll do this just one underneath, 20 cos 20. You can see by me taking it always between the x-axis, I've got all my sines going vertically and causes going horizontally. What the question means here, the resultant force is 3i plus 2j. That basically means if we resolve vertically, it will equal 2, because that's my j component. And if we resolve horizontally, the resultant will equal 3, because that is my I component. So let's resolve horizontally first. So I'm picking out all my green ones. I just colour-coded it nicely there. So we are going to have 20. Ooh. Just realised I labelled this one with a terrible arrow. Hopefully you were screaming at your screen. Should go like that, right? So we've got 20 cos 20 plus F2 cos 70 minus F1 cos 30. So all my right arrows take away my left arrows. And that equals to 3 from there. Okay, we'll leave that for the moment. Let's resolve vertically. I'll just drop that down a tiny bit. So let's resolve vertically. We've got F2 sine 70, and then so these take away the other two. So take away F1 sine 30, take away 20 sine 20, and that all equals to 2, because that was from the 2j. If these were nice numbers, this would be a really easy question. It would just be a case of simultaneous equations. But the fact that we don't have nice numbers and we've got pretty horrible values of cos and sine, except for the 30, it's a quite difficult question, just in terms of the algebra involved. So let's think of a game plan. We need to make probably F2 or F1 the subject of both. I'm going to go and make F2 the subject of both. Just because they're already positive. So if I make F2 the subject, then I can set them equal to each other, and that will eliminate the F2. So in red, I'll make F2 the subject. So F2 is going to equal to, well, if I throw everything to the other side, plus F1 cos 30 minus 20 cos 20. So I've added this to both sides. I've taken away this from both sides. And now I'm going to divide by this. So all over cos 70. For this one, I'm going to add this to both sides, add this to both sides, and then finally divide by sine 70. So that is going to be 2 plus f1 sine 30 plus 20 sine 20 all over sine 70. So from there, if we make them equal to each other, so f2 equals to f2, so that is going to be this top one here, 3 plus f1 cos 30 minus 20 cos 20 all over cos 70 equals to 2 plus f1 sine 30 plus 20 sine 20 all over sine 70. We can see here we've just got one unknown now, and actually everything else involved is just a number, like sine 30 is just a number, cos 30 is just a number, etc. In fact, cos 30 is root 3 over 2. So let's put that root 3 over 2 f1. And sine 30 is just a half, so I can put that as a half f1. Looks a bit nicer now. From here you can do a number of things. I'm probably going to cross multiply. So, to get rid of these fractions on the bottom. So, sine 70 all times by this, and cos 70 all times by that. Let's actually just figure out all these number pieces, kind of join them together, because they're all just numbers, right? So let's just do that. I'm going to do 3 minus 20 cos 20. So that's going to be, well, I'll still have the root 3 over 2 f1, and that's going to be minus 15.7938 5. Not going to write them all down because I know I'm probably going to be rounding at the end. 2 or 3 significant figures. So let's do the same here, half f1. So let's do 2 plus 20 sine 20. That's going to be plus 8.8404. Leave that one a bit shorter. There's no real good figures after that. It goes 02, so it's a bit pointless writing them. And then we just keep solving. It's such a boring question, but I guess it's one we have to know how to do. But it's pretty boring. So let's just multiply both of these by sine 70. So root 3 over 2 times by sine 70. There must be a smarter way to do this, but I'm going for the brute force way. And then sine 70 times by 15.79385. I'll just leave it like that. And then cos 70 times by a half, which is 0.171 f1, and then cos 70 times by 8.8404, which is going to get you 3.02359 and so forth. Let's take this from both sides. Let's add that to both sides. Change colour again. So 0.813797 take away 0.171. That gets me 0.6427 f1, and then 3.02359 plus 14.841 is going to get me 17.86459. Now I'm going to divide by that 0.64 business. And it gets me 27.796, so on. Well, let's do 3 significant figures. That is 27.8 newtons to 3 significant figures. And I'm just double checking that that is exactly what we wanted, and it is, thank God. So that's what we want for F1. Let's just scroll back and think, okay, let's take this one for F2 and chuck it into there. So I'm not going to show the substitution, but here I would just put 27.796 and I would type all of that in my calculator, and when I do, you would get 24.2 newtons after you'd rounded that to 3 significant figures. So I'd have chucked all of that in my calculator, but my calculator's not on the screen, so there's no point me doing it off camera because you won't even see it. So that's that question. Horrible. Pointless. Doing that with easier numbers would have been a much better spent of our time. But there you go. That's how you do that one. So question 7 and then question 8 afterwards. So this is question 7. A good question. I liked this one a little bit better because it was actually proper maths, not just number crunching. So let's have a look at the question. Let's get a diagram drawn from this. So a mass of 2 kilograms is going down a rough plane that is inclined of alpha to the horizontal. So let's draw that out. Nice big diagram. Alpha, we've got a block of 2 kilograms. So from that we know we've got 2g of the weight, and we've got the reaction force. We need to get our 2 resolved forces. We know that's also alpha. So this is 2g sine alpha, and this is 2g cos alpha. Let's see if the question's telling us anything different. A force P acts horizontally upon the particle of the plane. So that doesn't mean it's going to push it directly up. That means it's pushing it like this, horizontally against the plane. So the plane is the bottom thing, not the... oh no, the plane is there, but it is acting horizontally on the plane. That's how it would look. It's going horizontal upon the plane. Because of our Z angles, we also know this is acting at an angle of theta. So we'll use some more resolving stuff here. So we want to resolve this in terms of this direction and this direction, because they're the 2 forces it's kind of having an effect with. So the blue one is going to be, sorry, I forgot to label on, this is a force of P, so that'll be helpful in our thing. So P sine theta, and this one's going to be P cos theta. And I think, oh, not quite, we haven't done our diagram just yet. It says that it is, given that the coefficient of friction is 0.3, so I'll write that up there, the particle is moving at a constant velocity. It's moving down, so moving down like this, my acceleration's going this way. Because I'm moving at a constant velocity, well, my acceleration is going to equal to 0. I'm not accelerating when I am constant. And because I'm moving down the slope, friction is going up, is acting up the slope. It always goes against the way you are moving. First thing we want to do after we've done that diagram is deal with this tan alpha equals 3/4. So tan alpha 3/4, we know that that is the opposite over the adjacent from just trigonometry, so Cartoa. So the opposite must be 3. and the adjacent must be 4. A little bit of Pythagoras helps us find out what that length is, 5. So therefore, sine alpha must be 3 over 5, opposite over hypotenuse. And cos alpha must be adjacent over hypotenuse, 4 over 5. So then values will come in handy. We can see we can replace all of these things with them when we want to. Okay, we want to find the value of p. So first thing I will do probably is resolve in the that direction, the arrow I have drawn. Because I'm in equilibrium, that way I'm not moving, they'll equal each other. So r equals 2. I've got 2g cos alpha from here, and I've also got p sine theta. I guess I can leave it like that. I may as well replace these things. So 2g cos theta is 4 over 5, and then 3 over 5p. Can't really do much more with that, so let's just leave it like that for the moment. We can see we'll probably use this r in our mu r for friction. So I'll leave it with r as the subject. It'll probably be the most useful way of using that. Next thing I want to do, once I'm done with that, I'll start resolving the other way. So with this one, because we're moving downwards, I'm going to do all the downward arrow ones, take away all the upward arrow ones. I'm going to use F equals ma here, because we do have movement, but you'll see because of that acceleration of 0, it actually turns out a bit of an easier equation. So all the things pushing it down, that is 2g sine alpha from here, and then take away p cos theta from that pushing from p, and then take away mu r from my friction. And that equals to the mass 2 times by the acceleration 0. So actually that equals 0. So let's just rearrange that a little bit. 2g sine theta, well that is actually 2g times by 3 over 5 minus 4 over 5p minus, well, we've got a value for this. 0.3 is mu times by 2g 4 over 5 plus 3 over 5p, and that equals to 0. So let's tidy up this stuff with the g's in it. That can be 6 over 5g minus 4 over 5p. I'll keep it like that. Let's do 2 times 4 over 5, then times it by 0.3. That gets me 12 over 25g, so that's from this term. And then from doing 0.3 times 3 over 5, well, negative 0.3 times 3 over 5, remember? So minus 0.3 times 3 over 5. That is going to be minus 9 over 50 p. That equals 0. Let's join my numbers together. So let's do 6 over 5 take away 12 over 50. That's going to get me 24 over 25g. And then let's add these both to the other side and join them together at the same time. So I'm going to do 4 over 5 plus 9 over 50. That's going to get me 49 over 50p. So now I just need to divide by 49 over 50. So 24 over 25g, so I'll do times 9.8 now, divided by 49 over 50. And that gets me p equals to 48 over 5, or 9.6 newtons. That's not what I wanted 7.2. Alright, had a quick look, realised I did the calculation in red wrong. That should actually be 18 over 25. I must have just typed it in my calculator wrong. No idea how, but I did. So, let's just redo that. I hope we get 7.2. So 18 over 25. Perfect. We do. We get 7.2. You can also see over here, if you don't like dealing with the fractions, you could have times everything by 50 on this line, so that would have kind of got that to 60g, 40 minus 40p, 24g, and 9p, and then solved it like that if you really wanted to. That would have also got you 7.2 newtons. If you're comfortable with the fractions and just using your calculator, you can save yourself a bit of time by doing it like that. But that's how we do that question. I didn't make any mistakes until I just typed something in my calculator wrong. Okay, question 8, final one. So, this question, I'll let you read it. Let's get the diagram drawn from this. So, a particle mass is being pulled up a rough slope angled at 30 degrees, so let's draw that. So, a rough slope angled at 30 degrees. We've got a box of 0.5 kilograms, so a weight of 0.5 g. I'm going to do the resolving on this. This is going to be 0.5 g cos 30, and this is going to be 0.5 g sine 30. It's being pulled up the slope angle by a force of 5 newtons. This is the awkward bit. The force acts at an angle of 30 degrees above the slope. That doesn't mean that it does this. This is not what it does, okay? It acts at an angle above the slope, not an angle above the ground, an angle above the slope. So it in fact, oops, that's still me rubber. It in fact acts like that with a 30 degree there. So when I'm talking about resolving my forces actually acting on this particle or this box, we are going to have two things as so. We'll have something going up and something going across. So this is, well, it's a force of 5, so let me just fill that in. So this is going to be 5 sine 30, and this is going to be 5 cos 30. So that might be the thing that was tripping some people up. Finish off my diagram. We've got my reaction force, and we've also got mu r with my friction, where mu equals to 0.1. Diagram done. Colour coding helps, so if you are liking the colour coding, you can get some different colour pens and do this yourself. Let's resolve going like that. I always like to start with that one because it's always the one you don't actually do as much work with. So it's nice to do this, get it done with, and then do the chunk of it with the other resolving one. Does it say anything about movement? Yeah, it's being pulled up the slope, so we know we're accelerating that way. And we want to find the acceleration, so I'll stick an A there. So resolving up, I'm going to say r plus 5 sine 30, so that plus that. Well, that must equal to 0.5 g cos 30. We can in fact actually just find what r equals right now. So 0.5 g cos 30 minus 5 sine 30. So let's do that. 0.5 times 9.8 times cos 30 minus 5 sine 30. Not the nicest of number, but 1.74352. That'll do for now. That is accurate enough to go forwards with. I wouldn't round it to 1 or 2 decimal places. I'd round it to at least 4 or 5 there. So let's go for going up the plane like so. Could take a little sidebar here and say, well, my friction of mu r, well, that equals to 0.1 times 1.74, so on. So that we could say that's 0.174352. So we've got that value of mu r now. Not really much of a thing pulling it down with friction, but it's fine. So let's resolve going up. I'll do this below because I've kind of took a bit of that line over. So 5 cos 30. Sorry, again, I should say I'm using F equals to ma here. So 5 cos 30. Anything else going that way? No. So take away 0.5 g sine 30. Take away mu r. We know that's going to be that value. And that is going to equal to mass times acceleration, so 0.5 a. Not the most difficult solving here, I don't think. That's just a number. Let's just figure out all what this side equals. We can chuck all of this in our calculator, that left side, in one go. So 5 cos 30 minus 0.5 times 9.8 sine 30 minus that 0.174352. So 1.705775, probably don't need to go on that long, equals to 0.5a. So times by 2, a equals to 3.411, 5 and so forth. We've used gravity, so 3.4 to 2 significant figures, and that is meters per second squared. So that's question 8. So they were quite long questions. I'm quite tired now. All right, hopefully that helped.